Dive into the heart of progress with our Clean Mobility Policy Panel. Unveil the roadmap to a sustainable future as we discuss dynamic policies, indigenous self-sufficient supply chain, and robust product development. Join the conversation on empowering startups, cultivating innovation, and fostering a skilled workforce. This discussion isn't just about policies. It's a call to action. Let's enable the startup ecosystem, elevate product development, and empower the next generation.
On that note, it is time for us to introduce the next panel onto the stage. We have 3 panelists and 1 moderator. I'm going to request all the panelists to make their way onto the stage one by one, requesting the director, the Automotive Research Association of India, Reji Mathai, to please take the stage. Your job, people of the audience, is to put your hands together, clap for him. Welcome him to the stage. Joining him is co-founder and director, Log9 Materials, Pankaj Sharma, requesting you to please take the stage. Audience, your job is to make some noise. Put your hands together while he makes his way to the stage. Business Head, Commercial Vehicle and Construction Equipment, Anil Menon, requesting you to please make your way to the stage. And your moderator for this panel will be Dimpy Suneja, consultant at ARAI India. Dimpy, requesting you to please take the stage. Can we hear a big round of applause? This is your moderator. Those are your panelists. And it is time for us to begin. Dimpy, the honor of the conversation is yours.
Thank you. So I welcome you all for the panel discussion. The larger agenda of the panel discussion through the course of this discussion would be to identify and deliberate on various opportunities and challenges that exist for the larger electric vehicle value chain. As a matter of fact, Micelio Mobility, along with NSR Cell and RMI India, we've been trying to put together a compendium of cutting-edge innovations that can possibly sustain the ecosystem for the course of the next 5 to 10 years. We are hoping to sort of send this across to you at the end of the summit today as a primer, and it's basically like a teaser to what we're trying to sort of put together. The primer would encompass the initial findings that we had with about 30 plus interviews that we've done with a lot of you who are present in the room here with us today. But with that said, I would like to sort of welcome my panelists. We are really looking forward for the keen discussion. I'll transition to the panel discussion with sort of a quick question. And this sort of common across for the three of you. So India is witnessing this rapid EV adoption that's happening. So there's a transition that the entire automotive sector in India is going through. If you had to identify that one opportunity and that one trigger point that India has in terms of strengthening the EV supply chain as a whole, and if there's something else that India can do to further the opportunity.
Maybe I can start because we have been looking into testing certification of products in a big way. What we have, this I had commented in my opening remarks also, I was just mentioning to avoid the plug and play sort of a thing. Building a robust ecosystem of components is what is a need I currently am very much wanting to look forward to. The end product everybody is worried about, means everybody wants to showcase a big end product that the thing should look good and should be saleable and all. But if we have to really develop as a country, cater to the global needs, the component level manufacturing needs to be strengthened significantly.
I'll move to you.
Yeah, let's build it here. I think that's step one. I think last year the total global cell production was around 450 gigawatt hour. India bought 2 gigawatt hour of that. So when the drop goes to the ocean and tells the ocean to make it what it wants, it's never going to happen, right? But we want technologies for India, not technologies that were developed for somebody else. So you've got to start there, build tech grounds up, invest into innovation so that you've got control over building what you're building, And then you can serve the customer in the most truest way. And what I love to say is always is, for every tech company that's here, that's trying to build and trying to capture the EV space, feedback is the breakfast of champions. So go listen to the customer. Don't try and peddle what's available from the neighboring country as a solution. Go build it. And I think once you build it, you can fine-tune it. Imagine if Intel could only build Intel Pentium 1 and had no ability to make Pentium 2, Pentium 3, GPUs, and so on and so forth. So I think long-term investment, not short-term solutions.
See, today, if you look at this EV segment, there are 2-3 segments. One is your personal, we see personal two-wheelers, cars, and then you have a commercial, typical for commercial usage and all. So what a customer, we have seen that, he's looking for a total cost of operation. So we've seen that, whenever a EV purchase is happening in a two-wheeler, a typical two-wheeler, a vehicle which costs about 1,60,000, within 5 years, if you look at the EMI, which works out, and the cost of operation, within 5 years, this vehicle becomes free for him. So that is the kind of cost saving which is happening in this. I think there's a large opportunity available. Similarly, in the commercial vehicle segment, if you look at where, the commercial viability, if you look at, today we can see in the smaller commercial vehicle space, there are a lot of three-wheelers or the small commercial vehicle, a lot of customers are coming to purchase these vehicles, looking at the viability. Again, in this also, the total cost which works out is, in terms of per kilometer, it is very cheap. And maybe a finance tenure goes a little longer. But at the end of the tenure, the vehicle is a free vehicle for him after 7 years, where we can make more money.
Perfect. I actually build up on Pankaj's this thing. Long-term investment brings long-term gains. I'll start with that and sort of pivot to you, sir. In terms of regulatory and policy standpoint, what do you think is the lowest hanging fruit that can be addressed at the national level and at the state level to promote the larger ecosystem?
When we speak about this regulatory aspect, see, what is important to understand is the government looks at the bigger picture. The bigger picture is not just EV or not just the EV ecosystem. The government looks at the whole energy security, the impact on the ambient air quality. So how we fit in various aspects is what the government is primarily concerned about. So we may think that this is the best solution, incentivize it or let it promoted in a big way. There has to be other, what I can say, jigsaw puzzles to be put into its place so that the complete picture is very clear for everyone. Coming into that, when we say about what is the low-hanging fruit, so as the regulatory mechanisms tighten, what I'm looking at is like, one of the things is the CO2 CAFE norms, I can say, the corporate average fuel economy for the vehicles. Now, as and when it starts getting tightened, we know that it cannot be met by the fossil fuels. It cannot be met so easily by hybrids, like what Europe has been doing. Europe has brought it to 95 grams of CO2 per kilometers of emissions. So in your fleet, you have to bring in the EVs, the zero emission, like the fuel cell or the hydrogen ICE. That is where I believe the focus and the drive is going to be and has to be in the long run. And when that picture for the long term is clear, everybody knows that this is where I'm going to put my money, or this is where I'm going to invest to bring out more vehicles or more solutions out of it. As of now, we are at something like 113 grams per kilometers of CO2 emissions. Europe is at 95. The phase 3 is being discussed. So once this tightening happens, everybody knows you have to bring in more of zero emission vehicles. So I believe that this is one of the key regulatory aspects that is going to come. Along with it, as we evolve, because the IC engines has evolved over the years. Regulations have been tightened, brought in, many things have been surprises. For EVs also, this is going to be a challenging phase. The AIS 156 bringing in had brought in a lot of disruption challenges to many people. But on a timely manner, if we put the roadmap before us, saying that this is the roadmap to be followed, I think everybody has a level playing ground, and we can see a lot of evolution taking place in the long term.
Perfect. So since you mentioned AIS 156 version 2, my reflective question on that is that if there is this one, again, opportunity or that one advice that you have to share it with the startups that are, present here today, that for building a safer electric vehicle that's affordable and meets all the mandates and compliances, if there's an anecdote that you would share based on the years of automotive experience that you have for the startups here, what would that look like?
I think some of them are not so easy as I know, because we all are grappling with various challenges, particularly a manufacturer, he looks into his resources, the finances, what are he going to get into and all. Meeting the regulatory requirements sometimes is the least priority sort of a thing. They go into the minimum required, what is the minimum required. And that goes into the field, and then there are challenges you face. The digital twinning and all that now what we are doing now, like the energy, means the common engineering facility centers. See, there is a fault bank with the technology providers or the solution providers. What are the faults that normally you get? Even if your vehicles are not ready, even if your controllers are ready, even if what are the main equipments are ready, you can plug it into those. And out how your controllers are going to respond in the real situations can be simulated. So learning and discussing this will help you out in bringing out robust solutions. Rather than just saying that somebody has done in 3 months, I also should do in 3 months or 4 months. This is the best solutions available in the market. But such solutions, I know what happens is when you want to face a challenge, when you try to change it or augment it, you are with a black box. So it is the best way is to look into our own developments or go into technological solutions that are available, which can give you help in much faster way and address that.
Perfect. So I'm going to sort of build up on that and come to you, Mr. Menon. Since Dr. Mathai sort of talked about keeping it slow and taking it slow, but talk about, essentially the mass trigger for adoption for electric vehicles and what's the key for that. From an electric vehicle adoption perspective, financing would be the key, and that's one of the levers that we've been seeing that is getting a lot of traction over the last few months. The Government of India's World Bank and SIDBI's Evolve program is one such example that sort of puts across a huge pot of money for providing low-cost interest rates to electric vehicles. From your opinion and your expertise in the field, would Evolve be enough? Is that sort of a step forward? If not, what else should be done to promote electric vehicles?
Sure. So Evolve was launched with SIDBI and Niti Aayog. Both of them have launched that. So that was basically to help MSMEs in EV space to give them the access to a cheap finance, which has helped. And the aim is to have 30% penetration of EV by 2030. But then still, I feel that there are a lot of other avenues which are available. This segment is still not under PSL. So the PSL requirement is that banking needs to fund 40% of the BIC should be under priority sector lending. So Power Ministry has approached Finance Ministry that EV should be part of priority sector lending. I think if it becomes part of priority sector lending, it would definitely help the banks to go very aggressive on funding the EV. End-to-end customers, B2B, B2C, all that.
Perfect. And in addition to the Evolve, because it just looks at two-wheelers and three-wheelers, what about other vehicle segments that you think about? If let's say we're talking about buses or four-wheelers or cargo four-wheelers, what would your insight look like for promoting those vehicles?
Sure. So today, if you look at in two-wheeler space, perhaps our bank IDFC is the largest. IDFC is having the largest market share of about 52%. In our total portfolio of two-wheeler, we have 15% share of EV alone, whereas in two-wheeler 5% share is of EV, but we have 15%. And we would. The next question, sorry, was that?
It was largely about, apart from two-wheelers and three-wheelers, the other segments that can be promoted.
So the other segment, as you said, two-wheeler, of course, and three-wheeler, and as you said, in commercial vehicle, which is your trucks and buses, the basic issue what as a financier we see is the cost of acquisition is very high. If you compare a ICE bus and a EV bus, the difference is a ICE bus costs about, a fully built bus will cost about 60 to 85 lakhs, whereas an EV bus will cost about close to 2 crores. So the cost of acquisition is so high that, to get the viability, an operator, you'll find very few operators going for an EV bus because of first is the acquisition cost, and you'll find that the government is giving the subsidy to the operators who will attach their buses for the public usage, basically to the STU and all. So that is, rather I was talking to Mr. Mathai also, I would request that, if something can be done, if the subsidy can be passed on to a private operator, which is a huge subsidy, so the viability becomes very easier. So that is one. And the second thing is that, today also we see that, the dependence on the parts, the battery, the main cost of the vehicle is the battery, which is more than 1/3. So today also we have a lot of dependence on, maybe China, and thanks to government, the PLI scheme, production linked incentive, we are seeing, which is a welcome move. We are seeing that, a lot of startups are coming up, they are manufacturing, and that is one of the reasons we are seeing that, slowly the dependence is moving away from them. So that is something which we feel that if it's, if it's a battery which is made in India, where we, a kind of a reliability factor, as a financier, it will give more comfort to me.
Perfect. What better way to sort of come to my question to you, Pankaj? With regards to please.
I would like to add one more point. If you look at the truck space, I spoke about the bus. If you look at the truck space, we also see that, the gross vehicle weight of the truck goes up if it's an EV vehicle. So the payload which an operator can carry is 2 tons less. So he would always want a larger vehicle but a lighter one. But because of the battery, which is a 250 kV battery, which is very heavy, his actual usage of space comes down. So if something can be done on that aspect also, it will.
Perfect. Again, this question directly points to you. I'll start with the first part of where Mr. Menon left. The first part of the question being that we're talking about batteries, and who better to answer this question that, the ingenious works that Log9 has put together. If you're talking about a roadmap for battery production in India, and then further indigenization, and let's say we're talking about what chemistry would, these are the questions that most people in the room do not have an answer to. But from your perspective, running a business on similar lines, what do you think?
Yeah, I think we have to draw from, not from trends, but from first principle understanding. What tends to happen is you see a trend and you follow that trend, and that's what an entrepreneur is not supposed to do, is not to follow somebody, but to create a new path, a new understanding, and show it to the rest of the people that it can be done that way. Would you want a Tesla cell to drive a two-wheeler in Chennai? No. But why is most of the OEMs are buying that cell? Should I have an NMC? Should I have an LFP? That was the kind of question that was all around. Should we have fuel cell? If I dialed the time back 4 years back when we were just sitting on a table and a chair and we were thinking about what chemistry to bring in India, we looked at this very esoteric chemistry called the LTO, and we said that it does something, it doesn't do something. So with the first principle understanding, I think the selection of chemistry has to be driven by what the customer is needing for. Step 1, where do all of us park our vehicles? Do we have the luxury of a garage or just a home? On the 12th floor when you sit, your vehicle is parked 500 meters on the road. The Tesla model of charging overnight is not going to work. You need opportunity charging, right? If you need opportunity charging, you need fast charge, rapid charge. So okay, fine. Which chemistry allows you to do fast charge? The narrative in the market had always been, I want to have this fancy-looking car that's going to drive 300 miles. But you and I drive 50 kilometers. Why should I build a 300-mile battery? So smaller or maybe lower energy density can work here. You and I don't have connections in Congo. So hunch for cobalt? Can I have an alternate to cobalt? Can I have a chemistry that doesn't have that kind of dependence in supply chain? We all operate in 45 degrees temperatures. So why would I have a chemistry that was designed for North American 25 degrees? You start to put all of that together and say, okay, fine, this is what I need to meet, and then you decide the chemistry that you want to go with. That's how we went into a selection of a chemistry which was lithium titanate oxide, and it allows you to do all of that, charge electric vehicles faster than a mobile phone. This phone takes 35 minutes to charge. My electric vehicle gets charged faster than this. That's fundamental understanding of what we need to deliver. So I think that's where it all starts. Build your first principle understanding around your products, see what the customer needs, what India needs, and the selection of chemistry follows that. Rather than the reverse way, I go to China and say, okay, fine, NMC is available by kg, let me just buy it.
Interesting. I'll again and this is again like a common question where Mr. Menon left. We were talking about trucks towards the end of his sort of remarks. Yeah. We're talking about a vehicle segment that we haven't really seen on the ground.
Yeah.
And because of several challenges that it requires, an infrastructure that we're talking about, it requires a lot of financing challenges that, again, with leasing, who's going to own it, who's going to drive it, who's going to operate it, and all of that. But from a battery-centric perspective, because Mr. Menon spoke about GVW of the vehicle, what do you do to make a heavy vehicle lighter?
Yeah, let's make all heavy vehicles lighter. They should not be heavy. We should lose weight ourselves. The driver should lose weight first. So you have less 10 kgs to carry. There are ways to bring down the weight, right? Have a lighter driver to drive it. But why do we want to load up a 250 kilowatt hour battery pack to drive a massive thing on the road? Won't it be great if I can have, let's say, a 100 kilowatt hour battery pack that's driving a 50-ton GVW vehicle? We can achieve it. Well, you have to combine technologies there. So you take a fuel cell. That's an onboard energy generator. And that's an expensive energy, by the way. A fuel cell has well-to-wheel efficiency similar to to an ICE engine. What you spend to get the hydrogen, or in our case, it's aluminum, you draw that resource from the planet Earth, you convert it, you consume it in a fuel cell, you get 25% out, 75% gets lost. So a fuel cell can never compete on a $1 per kilowatt hour rate to a battery for short haul. But big vehicles are driven mid-mile and long miles. When you're trying to deliver apples from Kashmir to Delhi, there are no opportunity charging points in those mountains. You cannot have large battery packs. You'll never be able to spec a battery to a large truck. So in our opinion, mid-mile, especially long mile, heavier trucks and buses would be a combination where you pump in, let's say, a good fuel cell system. It could be hydrogen and aluminum, and then reduce the size of the lithium-ion battery. So you generate the energy through that, you consume the energy into pack, and then the pack becomes literally a driver of that. And suddenly your 50 GVW truck, one thing is the driver doesn't have to lose weight then.
Interesting.
Just maybe I will add a few more things to it, because structurally we had been working on this, and there has been a lot of interest on lightweighting of the structures, apart from what he was mentioning about the power source, that how can augment with fuel cell or a range extender sort of a concept. There has been one approach that has now been tried is on seeing that the body can be made of aluminum. This has brought down the weight by 30%. The chassis is still not touched, but the framework of the bus body meeting all the legislative requirement, this was attempted and this has been proven. So 30% weight reduction has been a significant amount, so that gives a lot of leeway to the battery vehicle to match the weight what they have with the normal IC engine sort of a application. The other area that people are now strongly looking is, particularly even for railways also, they are saying, why not go from MS to stainless steel certain applications, where you can reduce the corrosion tolerances, the maintenance goes away for the long run. The sections are much thinner because the strength is much better. There are a lot of varieties available. So this is one area that significant work is currently being done. And I can see in the long run, this can evolve much faster also.
So, again, same on the same subject. If we had to identify, let's say, 2 or 3 of those low-hanging policy interventions to actually make long-haul trucks moving, what would that look like? in a policy perspective?
The policy will be, means it will be not very specifics like what we can say about whether it should be a range extender or sort of a thing. But what I can say, the policy will be like, one I initially mentioned about the CO2 emissions, how the CO2 emissions needs to be brought into the bigger picture and how it needs to be tightened. That is going to be one thing that will be there as a policy guideline. The others maybe have to be looking into the financing part of it, because I believe that's a very key areas how government can encourage, because that is how the EV whole ecosystem has been now evolving for the two-wheelers or the FAME scheme they have brought in, which has seen too much of growth in that. Similar, some incentivization scheme or some plan, like whether it road tax or whether it is octroys or whatever it is, a toll tax, something they have to work on, because as of now, government has got many things in their platter. So they may be looking into what is the best option, and in the end they also have to look at the balance sheet also, what is the income they are getting and how they have to dispense it. So those things also have to be looked into. Other than that, I am not seeing anything big coming up. The zero emission trucking is a point of big discussion that is happening, and how it has to be pushed. So there may be a policy document coming from the PSA's office or something like that. I will not be surprised to see.
Perfect.
Maybe, I just wanted to intervene, rather to Mr. Sharma. Can we have because today, as I said, the cost of acquisition of this vehicle is too high, that too because of the battery. Can we have, there's a company called Blue Energy, which is into a non-conventional energy. They've started, rent a battery.
Yeah.
Where the initial cost itself, is almost as good as a less than ICE vehicle. So can we have something where, the chassis and the other things are sold, you can hire a battery? Can we, are we looking something like that?
Absolutely. At Log9, we've really experienced it. So one of our international investors, which is Petronas, has through them there has been conversations that we've had, and Log9 has deployed a lot of its vehicle on a BaaS model. So because we build the battery, we know. The thing about, again, go back to the first principle understanding, why is an electric vehicle expensive? Let's fundamentally ask that question. Why is it? Is it because there's lithium in it? Obviously, there's no gold in it.
It's lithium.
Lithium is 3% in a lithium-ion cell. What is the remaining 97%? It's aluminum, it's copper, it's graphite, it's polymers and papers and electrolyte. Does those things sound very expensive to have? Not really, right? We're paying for an innovation curve that a country spent on, right? Somebody had set that capacity and they want to monetize that capacity, and hence when you go and try and buy a cell, you pay $120, $150 per kilowatt hour. You indigenize that tech here, and you can start to produce things at a much capital efficient cost. So I think there is a way to kind of first reduce the cost of the cell, the battery pack. And then the second thing has to be done is when you produce a battery, you produce a cell, you want to understand how it's going to depreciate over 4 to 5 years. What makes electric vehicle expensive is not the upfront cost of the electric vehicle that much, but the cost to capital is so expensive today, right? If I were to kind of come to you and say, can you put some money onto this particular electric vehicle, you will ask me, it's an asset I'm going to lease in the market, give me a depreciated asset value in 5 years. But the developer of the battery who's got that cell from some place has no appreciation or understanding. Maybe the battery won't run even 2 years. So he says, I'm going to load up the risk of that asset upfront. And hence the leasing cost becomes expensive. So build technologies that can depreciate gradually, and you have models and predictive chemistries that say, okay, fine. For example, in Log9, when we did that, we saw our batteries can live for 20 years. So it says there's absolutely no risk for first 20 years. Now I'm going to reduce that out and I'm going to give a warranty of 8 years. That's fine. So predicting depreciated asset value makes your asset financeable, and then BaaS becomes, so then you go to a bank and says, don't fund the vehicle, fund the battery, and the BaaS starts to roll in, and the customer can pay for kilometers, right? So I think there are ways to do that. Technology sits at the center of unlocking finances, not the reverse.
Absolutely. In fact, what we've seen that, that's absolutely what we also expect from an OEM. But what we see is that, eventually they say that, 6 years is the battery life, which you said, if you're giving a warranty of 20 years is nothing like it, because that's where it comes to a kind of a, stalemate where people say that, if the battery lasts for 6 years and the viability comes in an EV vehicle, say it takes 7 to 8 years, so then what next? So in case it can last, then it's absolutely
But again,
fantastic.
on that note, the thing is that when we're talking about a larger value chain, we did talk about raw materials and like a supply chain in terms of production, but let's talk about that while your batteries may last for 20 years or 18 years. They're batteries that would go waste probably in the next couple of years because there was a huge uptake of electric vehicles that was there in the first 3 years of when the FAME came out. So you would have a huge scrap of vehicles, scrap of batteries that's just waiting to go to dump.
Yeah.
If we're talking about something like that and we're creating a circular sustainable circular chain of sorts, how would battery recycling, what can be done about it?
Yeah, very interesting question. So we've, as founders, have invested into a startup that's doing recycling of the batteries. So I think first thing is we have to put our own money into that direction, those who are in that position of driving that conversation and bring the know-how of how we are building the battery, give that knowledge to the recyclers so they don't know how to rip it apart when it's ready to rip it apart. The second thing is, what is it that you recycle? That's very important, right? If you take a battery, you cut it open, you get to the cell, and you cut that battery and you melt it down into some thermos and some chemical process, and you get to the elemental metal, then you're competing in an open market for metal-to-metal trading, right? Is it cheaper to cut open a lithium-ion cell and get that lithium, or is it cheaper to just go to an open market and buy lithium? It's cheaper there. Right, so right now the recycling market sits on recovery of cobalt because that's a supply chain security. It's not a price issue. You want to secure your supply chain or cobalt recycling is, and you get your dollar pricing for that. The way Logna has looked at it and what we are advocating about it is that recycling will go through 2 stages. We are in stage 1 of that evolution where everybody is trying to digest the entire battery and get the elements out. Some of them would be viable, some of them won't be viable. In about 7 to 10 years from today, what you will have is active material recovery. So a lot of that active material which is on the cell, if you can just take the cathode back or the anode back in the macrostructure without breaking down their macrostructure, the same thing which is like 200 times, 300 times more valued in the market. So this is called direct cathode or direct electrode recycling. There's some work that's happening, some success has happened. So that's second stage. And between these 2 stages, there is a stage where a lot of cell producers like us, when they manufacture, we generate a lot of waste. And sometimes it's easy to recover that half-formed electrode because your drying didn't happen properly and you have some scrap. So factory scrap has to be recycled separately. So I think we're looking at it from 3 perspectives, but recycling is very complex, economically not very viable today. But I think the gap has to come between, if a recycler is trying to sell what is recycled in the open market, they'll never be profitable. They have to sell it back to the cell manufacturer. How do you bridge this gap? Who's going to be the buyer of that raw material? So if my recycler can give me the raw material back to me, I'm ready to pay a premium because that's security of my supply chain. And I think that is what is missing in terms of strategy, policy, business alignment.
I'll come to you with a similar question, sir. So the government of India has a battery waste management policy at this point. It mentions about a larger portal at a national level where battery recyclers, refurbishers can really be sort of put online, and there has to be a mechanism at play. But let's say this recovery has to happen, and there has to be collection centers that have to be provided to make sure that recyclers get these products back. In that case, all of this responsibility falls on to cities, states who have to do it. At a state level, if an intervention has to be linked to the existing national level policy, what would that look like?
See, these are not so easily worked out solutions, I can say. Because again, each place has got, like government makes a policy, the implementation plan has to be driven down through a partnership model. Means state alone cannot say that, okay, we will make this available and all that. This has been the same case with the vehicle scrappage policy also. The scrappage was put into place. People are putting up plants but none of the vehicles are coming to them. The same challenges for even the battery will also come up. What is needed now is what are the outlets, what is currently happening, we have to look into it. Most of these black mass or things are being exported as of now. Should we make a policy, try to block them, so that then we can have a provision internally, people will looking into how it can be consumed. So these are interlinked, many of these things, and there are global players watching onto it, global thing. So any steps we take, we get mails saying that you are putting up a trade barrier sort of a thing. I know when we made AIS 156 and AIS 48, we got a lot of mails from countries saying that India is putting trade barriers for battery. And now they are adopting it because they understood that India needs it. Mm-hmm. So maybe these are steps in the long run, how it has to develop. But along with that, I will say one more thing. Currently, one of the challenges that is having the testing requirements on the testing system, the durability of battery is not tested. If that is put into place, people will have some assurance for financing and people will have some assurance on how the product will last. So this is an area that is being discussed as of now, and I believe in the coming days this will be put into place where the durability of the cell or the durability of the battery pack will be a matter of certification or matter of where it will be defined.
Perfect. So, I mean, one of the things that you mentioned that policy like this would come up with a lot of partnership and consultative approach that's adopted. Again, just pivoting on that, and this is again from a larger point of view of the value chain. The few things that are so far overlooked because probably there wasn't a need or there wasn't a business case was largely about one, there has to be allocation of funds at some level for fundamental research of components. What we saw in the automotive sector being strengthened was that the MSMEs were strengthened the most at the outset of the revolution that India went through. In terms of this collaboration and bringing on how skill development can be roped into it so that you have a skilled workforce that's provided to you to fabricate, to manufacture, and also just sort of have research projects, and that thinking or that thought leadership has to be for innovative products. If this is a collaboration at this point seems like a challenge, if this has to be addressed, what according to you, I mean, and this again an open question for the three of you, what according to you can be done and at what level?
First is to put your money where your mouth is. We've done that. We put about 100 crores in that direction for a program called RISE. We truly believe that there is a very famous saying in Africa, when the lion eats, the jungle eats. This is the line of innovation that you have to create in this country. Like, what is it that we are up against? We're talking about a country that's going to go through 500 gigawatt of renewable energy creation in the next 6 years. We're talking about 70% electrification of commercial vehicles, 30% electrification of private vehicles. We're talking about 200, 250 gigawatt hour of domestic cell production. We should do that. What is the path to do that? You know, will it be on imported licensed technologies? No. See, the challenge is when you license technology, you only know how to make it that day. You don't know how to improve it tomorrow. You're scared to touch any variable that they've licensed to you because anything that you change can change the outcome. And for creating that line of innovation, we have to go to the brass tacks. I think India has some of the richest and the most diverse brain in a younger populations which are there, and we've benefited. All of us have been in those ecosystems ourselves. We are here today because we were there one day. So, you know, my 2 cents on that is there are 3 levels of interventions that are required. One is aggressive investment from the government side and from the private side into innovation centers in India. To go to all the IITs and IICs and enable infrastructure there. Today, if you want to make a cell in India, you struggle to go find a cell line. I can make a coin cell, but if I need to prove how this material is going to hold on and all, I need something that can make a prismatic or a cylindrical cell. I have very limited resources to go to. If you have 5 centers in India where you can just walk in as a PhD student and get your material, raw material, new cathode material, fabricate it and get a full cell out of it with digital twinning, fantastic. So we need to invest into, first of all, fundamentally creating infrastructure. There are some places where we can go and learn to. Germany has Fraunhofer, and if you look at the Fraunhofer Institute, they have set up 150 megawatt hour of experimental pilot line for their institutes to come and try and do their chemistries. We don't have that. You may design the best aircraft. If you don't have an airstrip, where are you going to test it? So I think first is infrastructure enables that movement. The second is, on our path to indigenization, you want raw material to come from India. We talked about it, that lithium is only 3 to 5% in a cell. What are the other things? It's aluminum, copper. I should be able to get that from India, right? That is, aluminum I should get from India. We get Coke cans here pretty well. But India doesn't produce a square inch of battery-grade aluminum. So that means even if we go and mine what's been discovered in, let's say, J&K and get tons of lithium out, nobody will be able to use it because that raw material is not in a form which is battery-ready, cell-ready. So you need material science revolution. We need to invest, create a national level policy framework and invest in a direction where you go to material science laboratories in India and enable them and empower them at a scale to take raw materials and then convert them into battery grade materials. So your supply chain start to localize here. I get my aluminum, my copper, my carbon, everything is here. All I need is material science revolution to happen. And third is then on top of it, you have some gigafactories that are supported and PLI is in that direction. So we have in our World Cup match of innovation, we are playing the last 40 to 50th over, setting up the PLIs. But we need the Virat Kohlis to come and play the first 10, 20 overs of innovation, and then the middle order to create that abilities of material science, and then India wins.
Perfect. Any thoughts from this?
I have few, I completely agree on what he has been speaking, but what I would like to add is that we need to start early. We are late in many of these areas because we have seen this in our place itself. What we started somewhere in 2013-14 when the EV was just taking off has enabled us to set up a facility or capability which is best in the world, I can say now. So people come from abroad and have a look at it and say what we are doing or what capabilities we have. Like, do you need a charger to be tested, certified? We can do it. You need a battery pack to be tested. We are into making laws, regulations into that. So starting early is something that we need to do. Now, I know we have what he is saying about material science and all. We have missed certain parts because this was never a focus area. But now we have understood that, many of them. And there is a focus area now being built up, but it will take some more time. So, and many of our educational institutes which have some capabilities, somehow the connect between the industry or what is happening has not been, they have not been able to correlate and calibrate themselves or move ahead from what is happening. We need to equip that part also, that missing angle also. Once we do that, I think we are in a very good position because we have the best, the Fraunhofers. I had discussions the last year. We had a visit, so we could see how the projects used to flow to them. Funding from government, a percentage, whatever they were getting from the industry, a percentage of that the government will give. They will not question it. So if they are able to earn from the field 60%, government will give them another 30% to that. Say that, okay, this is our contribution for your research and for your own work. So this model works very well because it has got an accountability from them. They have to earn from the market. They are not at all looking to government for all funding. But there is an assured part from government for them to do the free research or whatever developmental work. So that is a very important model, and we would like that to happen.
No, perfect. Any last thoughts from you? I just had a closing question.
Yeah, I completely agree with both of them that the focus wasn't there. But if you ask me today, looking at the corporates, in fact, when I was coming to Bangalore, the cab which was booked for me, very specifically they said it has to be an EV. So that responsibility which comes on the corporate, we've some customers like JSW and all, they purchased a bus, EV bus only, though it is an expensive bus, but they bought it only for the employees. Today in our office, parking, you have a EV station. So a lot of effort, a lot of push comes from there. I think, at least in the corporate side, that push is there. In our KRA, it's there today, ESG. So there's a lot of work happening on that. I hope, it'll fructify in the future.
Well, this actually, good that you're practicing, but again, this is mostly to your point, Pankaj. This is a rapid fire for the three of you before we pass on to the audience. What is that one thing that makes you hopeful in the future of India EV transition and the supply chain being robust to meet all the challenges and opportunities just discussed today?
The average age of Log9 is 26. Every day that I come to the office, I see these extremely young, brilliant scientists have no understanding of where failure sits in life. And I think that ability to execute at speed is there. And the second thing is, when everybody comes to us, the designation that everybody gets is Chief of Climate Action. It doesn't matter whether you're CEO or the janitor of the organization, you're Chief of Climate Action. So I think what makes me very hopeful is that we are starting to ask the why of why I need to contribute my life in this direction, rather than what should I do. And I have a 16-year-old son, and I hope he sees the planet the way I saw it. Yeah.
Interesting. Anything from you, sir?
Yeah, I would only say that I think he took many of my thoughts. Means when I came over here, that was one thing. I was also very much happy to see the average age of the people sitting over here would be much, much lesser. I think that gives a lot of desire to do, go ahead rather than looking into what is pulling me down. Yeah. That thing is the biggest driver. We have our own technology group where Ujjwala heads it. So if you see, it's a very young group. And we see them striving to do things. There are a lot of procedural requirements. ARAI being a government organizations, there are a lot of procedural requirements. But still, they are so optimistic about the work and the way they will carry out. So I think I'm very optimistic of the fact because the challenges before us are there, but we have a very good startup ecosystem that is developing, that is taking it forward in the right direction.
Perfect. Any closing thoughts from you, Mr. Menon?
Yeah, sure. That in fact, rather I was thinking that maybe I can speak on the opportunities what we have, or some best practices which is being followed. I think that will be useful for the crowd also. As I said that this should not be taken as a product. We should consider this as a service. So service. You need to. We need to have a finance system where service. It can be a per kilometer kind of service. Again, because I go back to the same fact, expensive model. So what? Probably a lease model kind of thing in terms of finance also, where 7 years funding and lease model is given, where the residual value is bought either by the manufacturer or the bank, which works out very cheaper, which is what the European markets we can see that. And of course, again going back to make this viable and affordable, so that we'll have more and more entrepreneurs. Because we meet a lot of customers who keep coming to us saying that, because we try to promote it, but then they say that, make it viable and that's the best option we'll have.
Perfect. So the future of the electric mobility lies in the hands of the startups. We've established that through this panel discussion. We'll have the audience asking a few questions. We have time for about 2 or 3 of those questions. We'll collect all the questions together and then ask the esteemed panelists to respond to them.
Just put your hand up in the air. We'll have someone come up to you.
Yeah, good evening. Thank you for your time and enlightening us on the evolving EV scenario. The one question I have is, what we see mostly is the battery pack or the energy source is fitted onto the structure of an IC engine. So is it really matching? We have an immediate solution, I agree, but is the tires matching to the power output and the torque coming? If the gearboxes are tuned to that output, and will it give the life expected? So it's a quick fix, maybe sounding like a quick fix, but are we designing an electric vehicles or adapting a battery onto an IC vehicle structure? Thank you.
We'll have one more question and then probably, yeah, please, absolutely. Can we have a mic here, please?
I have my question to Mr. Pankaj. So we can see a lot of cell manufacturer, maybe lithium ion cell or sodium ion. At a maybe 100 cell per day or 50 cell per day, they may be doing it. But when we need to scale it up, how do you see, are they going to scale it up? Because a lot of investment is required, a lot of, scaling is a big task. How do you see as a startups, they are successful, but scaling, how they are going to do that?
Perfect. We have a question. Can we have a mic there, please?
Great panel discussion. Good to see you, Pankaj, again. So my question is to Pankaj. Pankaj, fantastic stats, where right now at 0.5% to the world's contribution to almost dominating the world with the largest percentage. That's what India has been set for. While I completely appreciate the call that the IITs, IIScs of the countries must be geared up to be really capable to handle the advanced level technologies. But don't you think such kind of a mass transition also needs an elevation in the skill levels of the other blue collars, especially the ITIs and the diplomas, who once were the backbone of Indian manufacturing industry? And not just for the Indian manufacturing industry, probably right now we see Japanese teenagers are assembling the batteries. And though Mr. Biden is pumping in lots of billions of dollars, there are no enough workers there. And of course, Europe has been struggling from the quality skill and the quantity skill for a while. Can India be seen as an alternative, not just for technology, not just for startups, but can India also be the powerhouse of EV talent to the world? If that were the case, what would be pioneers like Log9 and ARAI are doing, and how can we take this revolution forward? Thank you.
Perfect. We're going to start with answering this question first. I'll turn it over to you, Pankaj.
Yeah, I think it's not only the scientists. Like when John F. Kennedy went to NASA one day and they were trying to put they were building the rockets and everything, and he just happened to pull one guy, maybe a janitor, and he said, "Sir, what do you do here?" And he said, "I'm putting a man on the moon." I think because that entire organization just had one single North Star, which was to put one man on the moon. But it takes a crowd to do something that's meaningful. And I think we've experienced the same thing. About over 500 associates come and work for us at our factory, and if they are not there, the batteries won't get made. And I think that level of talent which we have in India, and these are some of those ITI graduates that came just as cell assemblers and battery pack manufacturers, have now moved into the R&D roles because they learned it so fast. And so what I'm recognizing now is, in the opportunity that we're having at this company, is that India has this younger population that has this insatiable appetite to grow and to prove it to themselves that they're good at it. No matter which education background they're coming from, if we give them enough training, enough resources, they're ready to put their hand up. They're very diligent. You don't struggle with them in terms of them upscaling themselves. So you're very, very right. While the IITs and IIScs can be called on to creating this fundamental material science revolution, we need to parallelly skill the hands and the minds that are going to build these battery packs for us. And I think shift the power out. I think India should be the nation that overtakes the other places, because we have the scale, the intellect, the ambition of people, and the maturity to handle a business of battery pack assembly here pretty strongly.
Anything to add?
I will just add a few more things to that, because see, the area of, if you see the skilling and all that, the IC engine had diversified fields. So battery is one area where I think there is manpower or skilling. But the whole EV requires a separate skilling, handling high voltage, how that has to be worked upon. So this skilling part, government has also recognized that there are modules now made, and I think there is going to be a certification course which is going to be put into place where the factory workers or anybody can take that course and be called as a certified person who can work on the EV thing. This is in place now in many places. Many of the factory people are coming to us for that. We work with many of the OEMs. They say, please provide this training. But going into directly to the college level, like the ITIs or the diplomas, this will be the next step that has to be done, because the existing skilling level of workers or reskilling of them is currently being taken place.
Perfect. Since we are, since you were answering this question, sir, we'll answer the question that the gentleman asked. That is, are we quick fixing the EVs, or we are actually sort of investing enough in developing a structure that's very specific to the needs of the vehicle?
So. Let me start with the retrofitment, because there is a lot of work that is thought of for retrofitment itself, means remove the engine part, let the differential be there, couple a e-motor, and put a battery pack, and you have got a e-vehicle. So many of them are seriously looking into it with certain applications. Say it's a garbage pickup van or within the city driving. So they just want to change it over because the fleet is there. It is not very old. Your drivers and everything is there. You don't want to come into a new vehicles to be bought. So can it be done? So a lot of structural studies are done before such things are carried out, whether the chassis can hold it, which place it has to be placed so that the CG does not get disrupted and all that. Coming to the tires also, yes, if you see how much weight has been replaced and how much it is added, how the distribution is done, these things are looked into. And always there is a factor of safety given to all such application. You may be knowing that government increased the weight carrying capacity of the trucks by some 10% or 15% through a simple regulation, saying that, okay, what you are allowed to carry like 20 GB tons can now carry 22 or 25 gross weight. So there were studies at the back end carried out. So this has been done. But as you rightly mentioned, maybe after some more studies, the tire augmentations or things like that, if needed, will be parallelly being done and are looked into. Because without that, the certification works and all that will not move ahead.
Perfect. We'll close with the most difficult question. How do you scale up cell manufacturing?
I wish I had a simpler answer to that. Yeah, through step processes. I think, we've learned the same thing. We started with a very small lab. We could build everything from our hand, and we could check it up, and the cells would be really perfect. And we realized that the devil is in the detail as we went into the larger, 50 megawatt hour cell production line that we set up a couple of months back. There is a penalty to pay to do it for the first time because you have no ecosystem. You have nobody to learn from. You make all your mistakes. You have nobody else's mistakes to learn from. We've realized that we have about 170 single point failures in our process when we set it up, no matter how we set it up. It's super expensive to do this stuff. It costs you about $75 million to $100 million to set up 1 gigawatt hour of cell production. So that means you have to be really sure that you want to do it for the rest of your life, and you have the margins built into it. But I think what cell scaling up is telling us is, apart from the capital deployment, capital dependency, it is purely process engineering. India is not very strong at process engineering, so we don't get good process engineers who've done it. So, for example, there are people from Intel that have built Intel chips that are working for us in terms of making us understand how to do this stuff. So I think you have to cross-pollinate in terms of your talent pool. You have to take the brave step forward. You have to put your first principle understanding, what you're going to produce out of that. And then, be at it. It has taken us several months to reach where we have reached. But I think it also gives you an opportunity to tweak and change the processes. The last dependency, the biggest dependency that we all have in our scale-ups is not the process. It's the equipment that goes into these assembly lines. You buy an equipment from a foreign country and doesn't produce cell lines, and when you buy equipment from outside, imagine if you have such an expensive setup running up and your calendaring machine drum starts to roll a little faster because the motor controller on it is not working well. And how do you fix it? You have to call somebody from Germany to come and fix it up. So I think indigenizing machines that make cells is again I don't know, I have you here so I can... But yeah, I think once you take that step, you will navigate through that. I think once you have the capital and the first principle understanding, it looked very challenging, but very proud to say that we're making cells. The cells have come out really well, and we will see shortly about 1,000 vehicles on Indian road made from India's first cells.
Perfect. Thank you so much for listening. This has been very insightful. I would really like to convey my gratitude to you guys for making this really insightful, and of course, Ms. Reji for hosting an insightful panel like this. Thank you so much. Thank you.